Number 1. Your experiment output as well as a quick run through on what you did in this experiment. So for this experiment, I used MATLAB to simulate the step response of a second order system. First, I varied the damping factor by changing the value of sigma while keeping the damp frequency constant. From the plots, I observed that when the damping ratio is low, the system becomes underdamped and shows oscillations with high overshoot. As damping increases, the response becomes smoother until it reaches critical damping and eventually overdamp behavior, where the response is lower but no longer oscillates. So the next step is that I varied the damp frequency. I noticed that increasing the frequency made the system respond faster, but it also increased oscillations and overshoot. I also explored adding zeros and poles. Adding a zero closer to the origin significantly changed the peak and rise time, while zeros far away had less effect. Similarly, adding poles showed that poles near the dominant pole slowed down the system, while poles far away had minimal impact. Number 2. Discussion on the challenges in performing this experiment or understanding the concepts. So one challenge I encountered was understanding how the formulas for natural frequency, damping ratio, and damped frequency all relate to each other. It was also a bit confusing at first to interpret the graphs, especially distinguishing between underdamped, critically damped, and overdamped responses. Another challenge was predicting how adding zeros and poles would affect the system before actually running the simulation. It required a deeper understanding of the system dynamics. Lastly, notes to self or anything worth noting. So first, always remember that dominant poles determine the system behavior, so anything close to them has a bigger effect. So second that I noted is that higher damping reduces oscillation but may slow down the system. Third, increasing frequency speeds up response but can introduce instability. And lastly, the simulations are very helpful in visualizing concepts that are hard to understand theoretically. So basically, in this experiment, it helped me better understand how system parameters affect performance in control systems. That is all.